Hello, sir. My name is Anubhav Gupta, 21BD004. Today, I am presenting you our project Language Translations Model. So, let's dive into it. So, our project dives into comparing translation model like MBAT 50, M200, and LLB 200, and Google Translate using Hugging Face pipelines. We use Bliss Codes to compare translation model and perform our analysis. And we also explain the technical details of Hugging Face platform. Why Hugging Face? Hugging Face is a deep learning library which is more focused around transformers. So it is fast and easy to use. Also allows us to use state-of-the-art pre-trained models for our various NLP tasks. It also supports many transformer architecture like BERT, GPT, Roberta, and others. So let's take an example. We used Hugging Face pipelines, which makes our task simpler because it abstracts a lot of things away from us. We install transformer from pip install transformer and we import pipeline from it. Then we create a pipeline object. So we say classifier equals to pipelines, and here we put task and the model. When we put our text in the classifier pipeline function, then the output comes as label positive and the score is 0.990. So Hugging Face pipelines, we call a pipeline to perform inference on different tasks. So it uses some parameters like tasks, models, config, tokenizer, and framework. In task, we basically define which task we want to perform, like text generation, sentiment analysis, translation, feature extraction, etc. And model, it take inputs model, which model we want to use, and config the configuration of the configuration that will be using by the pipeline to initiate our model. Then tokenizer used to encode data for the model, and framework, which framework you want to use, PyTorch or TensorFlow, and other parameters. Let's take our example NLLV 200. Here we simply installing transformer from Hugging Face, pip install transformer command. From transformer, we are importing pipeline, and also here we are importing auto tokenizer and auto model for sequence to sequence. So here we are using model name as Facebook and LLB 200. And what is auto tokenizer, you might wondering? So auto tokenizer is automatically selects the appropriate tokenizer for a given pre-trained model based on the model name or its type. And auto models for sequence to sequence LM is just a tool to load any sequence to sequence or encoder decoder model. So here we are directly initiating our pipeline function. C likes bananas, strawberries, and grapes. So our prediction will be उसे केला, strawberry और अंगूर पसंद है. So tokenization is a process of breaking down the text into smaller units called tokens, which can be converted into words or characters. So in this sentence, our text is C likes bananas, strawberries, in grapes. Text, the output will be input IDs and attention marks. Input IDs is nothing, just some random mathematical number which has some weights corresponding to the characters or sentence. So how exactly tokenizer work? We calculate tokens from our text. Like here we calculate tokenizer dot tokenize. Then we convert these tokens into some IDs. When we decode our text, tokenizer dot decode ID C likes bananas, strawberries, and grapes, we get our text back. This is our pipeline. So first part is tokenizer, then it goes through transformer model, then last part is post processing. So tokenization involves breaking down the original text into smaller parts called tokens, which is understandable by transformer model. These tokens can be at the level of words, subwords like byte pair encoding or even individual character. Then our model is the core element that executes NLP tasks. Typically it is pre-trained transformer model. After the decoder produces output tokens, additional steps may be taken during post processing. This could include actions like combining tokens back into words and sentences, that is known as de-tokenization.
Greetings, sir. My name is Chintan Chawda, roll number 21VDS013, and I am here to explain the cloud architecture of Hugging Face. So, given figure shows the cloud architecture of Hugging Face, which we have specifically created, which is based on the NIST cloud architecture, which is a standard industrial practice. The service model of Hugging Face is hybrid model, which is a combination of software as a service and platform as a service. The deployment model of Hugging Face is public cloud, as it utilizes the cloud facilities given by GCP and Azure, and its responsibility model is shared responsibility. So, in the end, we can say that Hugging Face provides ML as a service as a niche, which is a combination of software as a service and platform as a service. There are five major cloud actors, and first of them is cloud provider. The cloud provider is a company that offers variety of cloud services to the consumers. In the service orchestration, there comes service layer. It consists of various services which provider gives to the consumer. First of them is FreeHub, where people can share their ML models and data sets all over the internet. Second is Pro Account, to which people can leverage various services through subscription. Third one is inference endpoints that helps you deploy models on powerful scalable infrastructure managed by Hugging Face. Next one is Spaces Hardware that offers access to upgraded computing services like CPUs, GPUs to build your model efficiently and quickly. And last one consists of enterprises or organizations can leverage Hugging Face services, let it deploy on their own cloud platform so that they can build their model on their cloud platform. In the resource abstraction and control layer, Hugging Face abstracts resources mainly through their transformer and pipeline libraries, which helps users to quickly access pre-trained models and high-level APIs. Hugging Face also abstracts the underlying cloud architecture as being as a middleman between the cloud provider like GCP and its consumers. Currently, there is no physical layer for Hugging Face as it leverages the physical infrastructure of other cloud platforms. In cloud service management, it refers to the practices and tools used to govern the lifecycle of cloud services within an organization. For Hugging Face, it is user management, billing management, monitoring, logging, resource management, version control, provisioning, customer support, cloud integration of freemium model, and etc. Second, cloud actor is a cloud consumer. They are the end users who are going to use the cloud services which are provided by the cloud provider. In our case, it can be individual developers, research labs and universities, small businesses, or large enterprises. Hugging Face also acts as a cloud consumer by relying on major cloud providers like GCP and Amazon Web Services. The third type of cloud actor is a cloud broker. Cloud broker is a third party that acts as an intermediary between cloud provider and cloud consumer. There aren't any currently cloud brokers that specifically offers Hugging Face as a service. However, we can say that Hugging Face acts as a cloud broker. It isn't a traditional cloud broker, but they focus mainly on ML models, working with deployments offering flexibility and simplifying infrastructure for users. Underneath Cloud Broker, Hugging Face acts as a service intermediary between the various cloud platforms like GCP, AWS, Azure, and its cloud consumers. It also acts as a cloud aggregators by three ways. First, by aggregating various ML models. Second, by various ML datasets which consumers can use for their requirements. And third is cloud service providers, as it offers a unified API that allows developers to access and deploy these models across different cloud platforms. The fourth cloud actor is cloud auditor, and it is an independent third-party professional who examines the control and security practices of cloud service provider. Currently, there is no publicly known cloud auditors for Hugging Face. However, they perform various audits that are listed below according to the industrial standards. And the last cloud actor is a cloud carrier. It is a company that provides physical network infrastructure that transmit data from cloud providers' data centers.
Greetings, my name is Kashish and I'm going to discuss about the datasets and models used. We leverage data obtained from the IIT Bombay English Hindi corpus, which contains parallel and monolingual Hindi text. As you can see, image 1 is the IIT Bombay English Hindi corpus. Additionally, we augmented our dataset with the verses from the Bhagavad Gita. This dataset includes transliterations as well as Hindi and English translations for each verse. Image 2 is the Bhagavad Gita dataset. Now, I will give a briefing about the models that were compared so as to understand why we choose them to be compared based on their characteristics. M2M100, Multilingual Translation Model. This means M2M100 can translate between many different languages. Robustness and versatility. It's reliable and can handle a variety of translation tasks without breaking easily. Large language coverage. M2M100 can easily translate a wide range of languages, making it a good choice if you need to translate between uncommon languages. Elimination of pivot languages. Normally, translation might go through a middle language like English to translate between two others. M2M100 translates directly. MBAT50, multilingual sequence-to-sequence model. Similar to M2M100, MBAT50 can translate between many languages and considers the entire sentence for translation, sequence to sequence, not just individual words. High accuracy and contextual understanding. MBAT50 aims to produce very accurate translations by understanding the context of the sentence being translated. Versatility. Like M2M100, MBAT50 can be used for a variety of translation tasks. Pre-trained knowledge. MBAT50 is likely to train on a massive amount of text data, allowing it to understand complex language nuances. No language left behind 200. Linguistic inclusivity. This model focuses on supporting a wide range of languages. Advanced machine translation technologies. NLP 200 uses cutting-edge technology techniques to deliver the best possible results. Commitment to diversity. Similar to linguistic inclusivity, NLP 200 prioritizes supporting a variety of languages and cultures. Focus on real-world applications. This model is designed to be practical and useful for everyday translation needs. Google Translate, widely used machine translation service. Google Translate is one of the most popular translation tools available. Extensive language coverage. It supports a vast number of languages similar to the models mentioned. Benchmark for comparison. Because of its popularity, Google Translate is often used as a baseline to compare the accuracy of other translation models.
Greetings, sir. This is Rohit Chaudhary, 21BDS011. So, Blue Score is bilingual evaluation under study score, and it is a metric used for the analysis of translation models. It is based on the principle of precision. Precision is true positives upon true positives plus false positives. Total total number of correctly predicted words in a target sentence or a predicted sentence upon total number of words. Let's see an example. Target sentence is, "O Krishna, I desire not victory, nor kingdom, nor pleasure." And the predicted sentence by our model is, "O Krishna, I do not victory, nor kingdom, nor happiness." So how exactly do we calculate blue score? The first step is to compute precision scores for 1 grams to 4 grams. So 1 gram is 1-to-1 matching. Like in the target sentence, the first word is O, and in the predicted sentence, the first word is O. In the target sentence, second word is Krishna. In predicted sentence, the second word is Krishna, and so on and so forth. For 1 gram matching, precision will be 7/10. Like this, we will consider two words, O Krishna, Krishna, I. Then I desire, I do. And like that, we'll calculate precision scores for 2 grams, 3 grams, and 4 grams. And after that calculation is done, we'll calculate the geometric average precision scores. That is calculated as P1 to the power 1 by 4 into P2 to the power 1 by 4 into P3 to the power 1 by 4 into P4 to the power 1 by 4. Here P1, P2, P3, P4 are basically the precision scores for 1 gram, 2 gram, 3 gram, and 4 gram. We'll calculate the geometric average precision and then we'll come on to brevity penalty. As it is based on the principle of precision, and if the target sentence is only one word, for 1 gram, the precision will be 1 by 1 and it will be perfect. And that's why it will be misleading, as the model will say that I will only predict a fewer sentences or fewer words or to get more precision and more blue score. To nullify this, we consider brevity penalty. So brevity penalty will be 1 if the number of words in the predicted sentence is greater than the number of words in the target sentence, and e to the power 1 minus r by c if number of words in the predicted sentence is less than equal to the number of words in the target sentence. The brevity penalty will never be greater than 1. What exactly is the formula of blue score? Blue is equal to brevity penalty into geometric average precision scores. By multiplying both the things that we have just calculated, we calculate the blue score. Now let's go on to the results of our translation model. So we have experimented for various different models like Google Translate model, then Facebook NLB, then MBART 50 and M2M100, and we have calculated on the dataset of two things. That is IIT Bombay English to Hindi dataset and Bhagavad Gita dataset. So Bhagavad Gita dataset, we have all the shlokas from English to Hindi and Hindi to English. For Google Translate, the IIT Bombay dataset, the result is coming as 42.34, and for Bhagavad Gita it is 47.19. Most of the times the IIT Bombay dataset, the blue score is more, and that is because the IIT Bombay dataset has fewer words in a sentence or fewer sentences and so on, and Bhagavad Gita has complex words and complex sentences. That's why the blue score of IIT Bombay dataset is more than the blue score of Bhagavad Gita dataset. And I'll let you know that the blue score is calculated in percentage. Basically, the blue score ranges between 0 to 1. We can conclude from this that the Google Translate is the best model among the models that we have just taken. For Hindi to English, we can see that the blue score is generally more. As you can see here too, the Google Translate model is the best. Later comes MBART 50, Facebook and LLB, and then the M2M100. So conclusion. So our project aimed to find out the best models for translation from English to Hindi and Hindi to English, so that the people can know what exactly they can use for translation of English to Hindi. So if a person has to say something in English and he doesn't know Hindi, so we can translate from English to Hindi, so he knows now what model to use. And also we are taking a formal approach of how Hugging Face is used, and we are giving transparency on exactly how the model is generated, how the model is taken out from the Hugging Face, and how exactly Hugging Face works.
Thank you, sir, for guiding us throughout the project.